Hi, I'm going to work out some of the problems from your non-credit review for test 2. The very first question is find the measure of the angle theta given that theta is an integer when measured in radians. Before I answer the given question, I'm actually going to work out the concepts first. I want you to pay attention to two important keywords, an integer and the radians. And let's work out question number A. And I have already shown that theta 1 is in first quadrant. Even though it's not drawn to scale, still it makes sense that angle theta 1 will be an angle between 0 degrees and 90 degrees. But knowing in degrees is not going to help me. And sometimes the incorrect answers I get for this type of question is like theta 1 equals 60 degrees or pi by 3. So that type of answer is very common for this particular theta 1 angle. But this is not going to be correct answer. As you know, I asked for radians, so the degree answer is not acceptable at all. The other one is pi by 3. This one cannot be an integer value because pi is an irrational quantity. If you divide it by 3, it's not going to turn out to be an integer in the first place. So this also is not acceptable. So if you logically think that it has to be a radian measure and it has to be an integer, you have to relate the values in terms of real numbers. So this pi now comes out to be an approximate number of 3.14 radians. So this one halfway through will be 1.57 radians, and 3 times of 1.57 will be equals to 4.71 radians, and once you complete, this one will turn out to be 6.28 radians. So if I look at my theta 1, which is between 0 and 1.57, the only possible answer can be theta 1 equals 1 radian. If this makes sense, I'm sure you know the answers for every other diagram I already made. Let's work on question number B. And if you look at that one, it's an integer as well as radian measurement of this particular angle. So this theta 2, it's just past 1.57, so it will be theta 2, definitely theta 2 in second quadrant, so its value will be between 1.57 and 3.14. But if I think logically, it's just past 1.57, so my theta 2 will be 2 radians. Now if you look at theta 3, I'm sure you know the answer for this one. Theta 3 is pretty close to 3.14, so your answer will be 3 radians. Look at theta 4. Again, here I get sometimes an incorrect answer. The students sometimes think that since it's past 4.71, if I just label this one in radians, it's going to be, they sometimes come up with an answer of 5 radians, which is absolutely wrong in this case, because notice the angle I identified is definitely turns out to be an acute angle, right? So but this angle can only be generated by, if you think about the standard angle, your initial ray is along the positive x-axis and the terminal ray will determine the measurement of that angle, and you can generate this angle by going clockwise only. So this angle turns out to be a negative angle. It is between now 0 and negative 1.57. So the only possibility for this type of angle, theta 4, will be negative 1 radian. And just the same, type of concept, if I would have marked my theta 5 this way, that means you can only generate this angle by going counterclockwise. In that case, you have to know that it is past 4.71 and it's counterclockwise, so your angle will be a positive angle. So theta 5 in this case comes out to be 5 radians. I hope this makes sense. This time I'm going to work out a few problems based on conversion of angle measurements from degrees to radians, radians to degrees. The first question, let's say I call this one as my question number 2, and convert the radian measure to degrees. And I will work out with two different problems. The first one is 6 pi by 5. So 6 pi by 5. You have to convert that in terms of degrees. Since it's in radian, I want you to start with the very basic relationship, which is pi equals 180 degrees, so that you do not make any mistake in thinking about the multiplier. So 1 radian will come out to be 180 degrees. You are dividing both sides by pi, so that's the multiplier you need to consider. So if I already have 6 pi by 5 radians given, I'm going to multiply this by this multiplier, 180 degrees over pi. And now pi got cancelled, and if you just simplify these quantities, it comes out to be 36, and 36 times 6 comes out to be 216 degrees. So that's pretty simple. That's for part A. For part B, notice I'm given 6 radians. I have to convert that in terms of degrees. And this is the type of problem where students can make a mistake very easily. When I give you something like 6 radians, I need to use that multiplier, which I already figured out right from the previous one. So that's the multiplier I'm going to use, and I must take the calculator value for pi. So I'm going to show you what it comes out to be. 6 times be patient just to show you the steps. I'm going to do 6 times 180 degrees divided by pi, and I take the calculator value, and it does come out to be 343.7746771 degrees. But this one actually requires, I didn't have the rest of the question for this particular one, but it does require you to answer in degrees and round it off to the nearest minutes. So what I'm going to do is basically 343. You could actually utilize the calculator, since you already have this resource available during test time. You may want to apply that resource. So it will be second and angle, which is this apps button, and if I select choice 4, it will convert that in terms of degrees and minutes and seconds. So I know it will be my 343 degrees 46 minutes 28 point something in seconds, right? But I need to modify that to the nearest minutes place. So if you notice, I need to look for my seconds part, which is less than 30 seconds, so it actually doesn't round it up. So it will be basically 46 minutes. It will not be 47 minutes. Remember that part, because this is less than half a minute. Okay, so that clearly, but the common mistake, I want to address that too. A lot of times students actually have a misconception of a radian as pi, but that is totally incorrect. idea, because radian is the unit and pi is a specific value for that angle. So basically, pi, if I ask you to find out your 6 radian, and if you wrote it down something like this, 6 pi times 180 degrees over pi, and you simplify, pi got cancelled. When you multiply, it does come out as a very nice integer value for that degrees, and that's could be one of your choices in the multiple choice answers. And if you select that, that will go wrong, because I did not give you 6 pi, 6 radians and 6 pi radians. They are totally different numbers. So I did not give you 6 pi radians, so do not write that down as 6 pi. Whatever is given, that's the radian measurement you take and then calculate. So this is not your correct way of writing the problem. Okay, this time I'm going to work on the third question, which is from degrees to radian. This is the conversion I'm going to work on. So if you know 180 degrees equals pi radian, you know how much will that be when it's 1 degree. So you already know the multiplier. Okay, so if I'm given that 71.37 degrees, I want to convert it in terms of radians. I just use that multiplier and plug it in the calculator and round it off to the nearest whatever that digit is given. You just do that calculation. Okay, so that's pretty simple. And for the second part, which is my choice B, the question number B, it asks you to determine negative 300 degrees, and your answer must be given with exact answer. Okay, it's not going to be a rounded off decimal number. That is a keyword, exact. So you cannot just take the decimal and answer that way. So what I'm going to do is use that multiplier. Okay, and see, you can simplify by taking out the common factors, and I can recognize that 6 is a common factor, so definitely 0 got cancelled. I can actually divide it by the whole thing, 60, or you can do it in with the common factor of 6, that's fine too. But this one I know for sure this will be 3, and this one will turn out to be 5, and my answer will be written as negative 5 pi over 3. You should not take the 5 over 3 from the calculator and give me an answer in terms of decimal. It has to be written with an exact answer or an integer answer. So that's one of the other keywords you must pay attention to. The fourth question, this is a little tricky but very simple idea. A lot of students actually asked about this particular question, so I decided to address the common mistakes what they are making in the lab. I have noticed. See, this one talks about a printing press has a roller 16 inches in diameter. A point on the roller surface moves at a speed of 77 feet per second. You have to find out the angular speed. So most of the students already did this basic relationship, v equals r omega, where omega is your angular speed and your v is the linear speed. So when I'm asking you to determine the angular speed, all I'm asking you to find out your omega. So you know how to come up with the simplification. So it's v over r, and students punch in the v, which is in this case given to be, if I look at my v, that's 77 feet per second, and r is given to be, actually diameter is given, so d is given to be 16 inches, so r comes out to be 8 inches. All of these things are very correct when you are writing down with all the details in the step. Okay, now if I plug it in the calculator, I get 77/8. So, and if I answer that way, it will go wrong. What I want you to pay attention is that you have to write it down with the units. And if I write down with the units, notice I have already done this part. So I wrote down with the units 77 feet per second over 8 inches. You cannot carry out the problem with two different units, so you have to take care of the units first, and I did by 77 times 12 inches per second over 8 inches, and inches got cancelled, and now I'm left with 77 times 12 over 8, and plugged it in the calculator and got the answer of 115.5 per second. That is my answer. And if the angle is without any unit, you know it's basically defaults to radian, so that's why I wrote it down as the final answer as omega equals 115.5 radians per second. Okay, now let's continue with the last question for this part, which is basically, I will again label this one as my question number 5. And here it is shown as radius 3 for that circle, and an arc length is given to be 6. You have to determine the angle measure theta in radians. If you remember the definition of the radian, you can easily figure that out. Since the arc length was 6, you can utilize that relationship. I hope you remember that. S equals r theta, and r is already given, and s is also given from the diagram. So if I just plug it in, I find out that theta comes out to be 6/3 equals 2, which is basically is the answer I'm looking for. And since I didn't have any units written, it is basically 2 radians. Now keep in mind, every time you work with a circular path or pattern, you know, your angle will always refer to a radian measurement. That's one of the keywords. So now if you look at the very next question, which is find the area of a sector of a circle having radius r and central angle theta, I'm pretty sure you may already notice something very important. Here r is given, theta is given to be 145 degrees. So if you remember the area of a sector, it's given by half times r squared theta, and r is given, theta is given. If you just punch in the calculator, you will get an incorrect answer, because you have to be careful to convert your theta in terms of radians. So that's the keyword. You have to pay attention that it has to be in radian value. So I will actually convert this one to radian measure, which is pi over 180 degrees. Degrees got cancelled, and you just simply put it in the calculator and get the answer. That becomes your theta. So once you punch in all these values into the calculator, half times r square is basically 100, right? So 10 square times your angle in radian value. So that's 145 pi over 180, and just simply plug it in the calculator and round it off to the nearest tenths place. So if I do that, 145 times pi, and then that's basically times 100. Sorry. So after plugging it in, I get the value of 126.5 rounded off to the nearest tenths place, and that's in meters square. That's the final, sorry, mile square. I'm sorry about that. mile square. That's the final answer. Okay.